Welcome to eVidyalaya lecture series for postgraduate courses. Today we are discussing about cryptography network security. Under this topic we are going to discuss about modern cryptography. So the concepts what we are going to discuss under modern cryptography is symmetric cryptography, asymmetric cryptography, public key cryptography, digital signature and digital certificates. So in the earlier system before this modern cryptography, we usually have the shared key cryptography. So it is a simplified model of conventional encryption. Normally the user, if they want to send a secret information, first they need to share the key. The secret key must be between the two users, the secret key shared between sender and the recipient. So when a person want to send a secret information, first he need to take the plain text. From the plain text he is going to send it to the encryption algorithm, as we are already discussed in the earlier lectures, where this example it is mentioned as DES is a data encryption standard. So one of the modern cryptographic algorithm where they are going to use the shared key, that is the secret key between the sender and receiver. Once they are encrypted, this content is going to be transmitted through the channel and the receiver is able to receive the particular message. With the help of the shared key, again they go for the inverse of the encryption process, is called decryption algorithm. So this is a reverse of your cryptographic encryption algorithm, where it is going to convert the non-readable text format, that is a ciphertext, into a plain text. So this is what we have discussed so far. So how it is going to be handled for today's internet environment. So modern cryptography is classified along three independent dimensions. The type of operation used for transmission, that is how it is going to be transferring the plain text to the ciphertext. This is what we say as an algorithm. And the number of key used, the main thing here is the secret, how secret we are going to keep the key, that much it's going to be secure. So the number of keys used depends upon what kind of cryptographic algorithm we are going to use. For example, I am going for a symmetric key, they use only single key algorithm. In asymmetric key there are two keys, namely we can say or we can say it's a public key encryption, the way in which the plain text is processed. So when we want to understand the cryptography, these are the three dimensions we need to understand. So first thing is we need to understand how we are going to transform the plain text to the ciphertext. In the classical crypto system where we have seen various algorithms, in that we are taken a plain text. For example, I want to say hello, hello is going to be shifted, then it is going to convert into a non-readable format, that is human may not able to understand what exactly the content is, that is what we say as a ciphertext. So the operation used for transformation, that is what type of operation they are going to use, how they are going to use, that is we need to understand. Then either I go for a symmetric key or asymmetric key, that is also going to be decided in what way I am going to communicate with my receiver when I am going to send a particular message. And also we have to understand how the plain text, in what way the plain texts are going to be processed. So this is the core idea behind the modern cryptography. So very important aspect, as we mentioned, the key. So what is a key? It's a input for a particular algorithm apart from your plain text, where this key is used to encrypt the content. So it is very important to decide the size of the key. So normally when we are going for modern cryptography, we are not going to consider the alphabets, instead of that we are going to consider as a binary zeros and ones. So hence it is mentioned as bits. So when I am deciding on the key size, because the key size is very important component, when I am going to choose a very small size key, for example I am going to take only 2 bits, then it is very easy for me to perform an exhaustive search, key search. 2 means, for example, I may have 0 combination, 0 combination, 1 0 or 1 1. So there are only 4 possibilities. So it is very easy for an attacker with the without knowing the key, he can able to get back the particular message. So that is a table which is explaining about how much difficult for a attacker to break the algorithm without knowing the key. Is based on the size of the key. For example, I am taking the 32-bit size key. The number of alternative keys is possible, it is 2 power 32, that is 4.3 into 10 to power 9. The time required at 10 to power 6 decryption per microsecond. For example, I am attacker, if he is receiving the because you are going to send the particular data over the internet, if for example is an attacker, he want to capture the information, he can able to see the information, but without knowing the key it is difficult for him to get back the key. But here what they are trying to do is, if I am choosing the key, they will decide based on the size of the key, they can able to break. For example, I am going for 10 to power 6 decryption per microsecond, then if the key size is only 32, then automatically it will take only very less time, that is 2.15 millisecond it takes me for breaking the particular key. So what we can able to understand from this particular concept is, when I am choosing the key sizes very small, then an attacker can able to break the system without knowing the key. So similarly, you can able to see the size of the key is going to be 56 bit, then you can able to see that it takes around 10 hours. If it's going to be 128 bit, it takes around 5.4 into 10 to power 18 years to break the key. So it is very important for an algorithm. Even if you take 168, you can see that 5.9 into 10 to power 30 years it will take for a person to break the particular system. So what is an exhaustive search is, without knowing any information, they will go for trial and error mechanism to break the particular system. So in that aspect, our key size is very important. How we are going to choose the particular key, that will help to secure our algorithm. So this is the basic thing where you need to understand how I am going to decide the size of the key when I am going to create an encryption system. So based on the shared key, as we know, when a person want to send a message, definitely they need a key. So this example is explaining about a shared key mechanism. In this shared key mechanism, a sender, if you want to send a particular information content with a briefcase, suppose this briefcase is going to carry this particular content, how they are going to use for the encryption, it is an analogy where you can able to understand the sender securely receiver securely a copy of shared key, that is sender need to receive the securely a copy of the shared key, positively identify the message of the receiver. So when I am going to send a particular message, sender, they have to share the copy of the key, that is the first step. So before going to start, these two persons, the sender and the receiver want to communicate, first thing they need to share the key, that is the shared key copy, both must have the particular key. When they want to send it, they will have a padlock and a shared key copy. So using this padlock and shared copy, by placing the content in the briefcase, they will lock the content, this message is going to be send it over the internet. When there is no person intermediately, for example Eve is not there, then the thread posed by, okay, Eve is not there, not an issue, the receiver will receive the message, the receiver will securely a shared copy where is going to be receives the securely a shared copy key copy, positively identify the message sender and detects any tamper with the message. So as we understand, they will detect if somebody has modified or not, that information also very much important, right. Now everything is going to be sent as a encrypted content. Even if this intermediate person is going to be present, that person may be an intruder or advisory where they can able to forge the key and view the content. So this part is very important. How? Even because we cannot say all the time we are going to send the particular content over a internet as a secured manner. So at any point of time we may face this particular problem where the advisory or the attacker or the intruder may pose a threat over your system. So how they pose the threat, right, how they are going to thread, first thing is they may forge the key and view the content, or sometimes they may go for damage and substitute the padlock, and damage destroy the message, and sometimes they go for observing the characteristics of the message. We have already seen the role and also what are the role they will play in the case of your threats. As we know, some people will be an active attacker, some people may be a passive attacker. So if it's going to be an active attacker, he will forge the key and view the content. Damage is substitution of padlock, damage and destroy the message. If it's a passive attacker, observe the characteristics of the message. So you want to monitor what is happening between the sender and the receiver. So this situation is going to be happening each and every time where we need to ensure the security. So in the symmetric key cryptography, that's what shared key cryptography or symmetric key cryptography. So the name symmetric key mentioning that is going to be a public key. Sorry, no, not a public key. It's a shared key. So when I want to send a plain text input, is going to be sent to an algorithm called encryption. Apart from the input of your message, it is also using the key. So that is going to be encrypted, and we can able to understand this. Okay, the quick brown fox jumps over the lazy dog is encrypted into an unreadable format. This is what we call this as ciphertext. Even the adversary is able to look into the particular content, he may not be able to understand what exactly is going to be sent. And on the receiver side, you can able to understand both are using the same key, that is why it's called symmetric key. On receiver side, where the same ciphertext content is going to be received and going for the decryption process, this is going to be convert back to the plain text exactly what the sender is sent. So the concept here is they are using, both are using the same key, it's a shared secret. So what are the problem, right? Suppose I am going for a symmetric key. So what are the positive and negatives, that is the pros and cons of this symmetric key is the strength. Simple and very fast, okay, order of 1000 to 10,000 faster than asymmetric key mechanism that we are going to see next. So asymmetric key, they are using the 2 key instead of 1 key. That mechanism is going to be compared here, where the strength is going to be very fast and super fast, somewhat more secure if you done hardware. Suppose we have a hardware itself going to do the encryption instead of software, then it's going to be much more faster than when we compare with software mechanism. Where you can take some example like a triple test, and also we have a Randall algorithms. The weakness is must agree the key beforehand. It's very difficult in the case of your symmetric key, because we cannot expect all the people are going to be having a secure connection with us. Suppose I want to send a data to X or Y person, I don't know where he is located, I just want to send his data, where it is very difficult for me to agreeing on the key beforehand when I am going to send the content, and securely passing the key to the another party, and that is also one of the challenging of symmetric key. So when you are considering the strength is very fast, this algorithm compared to your asymmetric key, but the difficulty what happening here is the key need to be shared. How we are going to share the key, how we are going to securely share the key without the advisor or threat is going to be happening with the particular system. That is the challenging of this symmetric key. In the public key cryptography, where it is a private secret cryptography uses 1 key, where we discussed the previous symmetric key cryptography shared between both the sender and receiver. If the key is disclosed, communications are compromised. Suppose the person who is standing middle between the sender and receiver, he is able to forge the key, then there is no security at all. So we cannot able to ensure the secure system. So that is a difficulty. So keys used in the parties are equal, no protection from sender for receiving, forging the message and claiming it sent by the sender. So that problem is also there. What is that? It's no protection of sender from receiver forging a message and claiming it is sent by the sender. So we don't have any proof that is sent from the particular sender. So that is also lagging in the case of in the symmetric key cryptography. In symmetric cryptography, we have discussed about the key distribution problem. Let us take this particular, when you are going to take this particular graph, if A want to share the key with B, C, D, then we can be able to understand how much key need to be shared, then only they can, all the 5 members can have a secure connection. So that's a situation where you can able to have a graph, a complete graph with n nodes. So nC2 is equal to n into n minus 1 divided by 2 pair key secrets are required for making all the people to have a secure connection. Let us take an example. In the case of n is equal to 100, then 99 into 50 is going to 4950 keys are required. Then imagine if it's going to be entire people who want to make the communication over the server or a particular other person, then it is become very big value. It is also not practically possible to share the particular key. So that is what we are suggesting as the key distribution, that is what we are mentioning as the key distribution problem. So key distribution is very difficult. Let us take this example. Managing large number of keys and keeping them in secure manner is very difficult. So that problem we face in the case of your symmetric cryptography. Secret keys are required between, for example, A want to communicate with B, then A and B need to have a secret key, A and C must have A and D, A, E, B, C, like that. Each and every user, they need to maintain a key between each and every user, then practically it is very, very difficult. That is what key distribution problem. Now we are entering into the unshared key concept, that is asymmetric key concept. So earlier we see that sender will send a content with a briefcase where receiver will open that. Before that they need to share the key, but this case is entirely different, where here you can see that when I'm not going to send the particular shared key, then sender padlock where the sender where it's going to be sending the particular briefcase with the help of the key which is going to be put in the padlock, then receiver will have a receiver padlock, then he put his own padlock. So there you can able to see that there will be two locks. So when I have the sender's key as well as the receiver's key, then only I can able to open this particular thing. So this is very, very difficult in practical scenario, as we can able to see that first sender use one padlock, then it is going to send to the receiver, receiver use another padlock, then I need both the key. This concept is similar to that of what we have in the banking system. So where they have a locker, the locker will have, bank person will have one key and the customer will have another key. If both are going to be used, then only they can able to open the particular locker, otherwise it's not possible. So this is what happening in the banking system, but it is in internet. Suppose I am going to have such an unshared key concept, then the briefcase has to be sent back and forth 3 times. It seems very inefficient. So that is need to be overcome with the public key cryptographic system. Probably most significant advance in the history of cryptography, we have used 2 keys. So one key called as a public key, another key is called as a private key. So what is the idea here is, I use one key for encryption, another key for decryption. That is public key, one key for encryption, another key for decryption. That is, I will use public key for encryption and a private key for decryption. The knowledge of encryption key doesn't given knowledge of decryption key. This is what the core idea behind the public key crypto system. So knowledge of encryption key does not give a knowledge of encryption key. So a person who has a public key, he cannot derive the private key. That is very, very difficult. That is also challenging task, which made the system still able to survive. So knowing the public key, it is very, very difficult to derive the private key. So what is the purpose of private key? Private key is used for encryption process. What is the, private key is used for decryption process. Public key is used for encryption process. So asymmetric key, since the parties are not equal, that means encryption they are using one key, decryption they are using different key. So they are asymmetric, the parties are not equal, use a number theoretic concept to function and also complement rather than replace the private key cryptography. So this same example, a person, if he want to send a content using the public key crypto system, we can take this example. You use the content. First thing, if I want to send a message to a particular person, suppose I want to send a message to a person, first thing I need the receiver's public key. If I am a sender, I want to send a message to, secretly send a message to another person, first thing what I need is, I need his public key. So that is what happening here. So before start sending the particular message, I need to know the public key of the receiver. So the receiver distributes the padlock to the sender. It is not going to be a secret information because it's called a public. So anyone can able to get this particular information. It can be posted anywhere in the public website. I want to share this particular information, I can put anywhere, and whoever want to send a secret message, they need to use this public key. So that is what happening. Now we can able to understand here, the sender takes his public key, this public key belongs to the receiver. Now he is putting the content in the briefcase, he is locking it and is sending to the receiver. Now what is the situation? we are not using the public key for opening the particular briefcase, we are using the private key. So that is what the difference between your symmetric key and asymmetric key. So earlier we use the same key for both the encryption and decryption process, but this case it is different, where we use the public key for encryption alone. We cannot use the public key for decryption. Private key used only for decryption, not for the encryption. So now we are clear what information need to be kept secret is the private key. What information need to share with the public key is the public key. So when I want to send a message to a particular person, first thing I want to get his public key. Where I can get the public key is from the any particular mode. It is not going to be a secret information. It is not need any security mechanism. Just we can able to post in the website also. So the issue related with public key crypto system is developed to address two key issues. One thing is, earlier we faced a problem called key distribution. So in that symmetric key, we have come out with a particular say if I am saying 100 users, then I need to go for around 4950 keys need to be generated. That is a thing where it can be overcome. Key distribution, how to have secure communication in general without without having to trust a KDC with your key. Then digital signature. These are the two issues related to the public key. So one thing is key distribution, how to have a secure communication in general without to trust the KDC with your key. That means how I believe whether this public key belongs to this person. Who can guarantee me that this key belongs to that particular person? That is the question is arise due to this public issue. Another thing is digital signature. How to verify a message comes intact from the claimed sender. Suppose I am sending a message, digital message, how I can able to verify whether it is from person A or B. Suppose I am receiving a message, C is receiving a message, how I can verify whether this is sent by A or B. So that is overcome with the help of the digital signature. So earlier we started with the symmetric cryptography, there we faced an issue of sharing the key. Later we overcome with the help of public key crypto system, where there is no need to share the key, simply the user publish their public key, anyone can in the public can able to send the message. But when I am using a public key cryptography, still I faces another problem is where I able to decide or trust whether the key belongs to the particular user, that is the key distribution process, and also how to verify whether the message is coming from the sender. This is overcome with the help of digital signature. So the two keys were Alice, Bob and Charlie. If you have 3 users, they have to, each and every user in the case of your public key crypto system, they have to maintain 2 key. First they need to generate 2 key. For example, Alice need to generate Alice private key, Alice public key. Similarly, Bob private key, public key, Charlie private key and public key. So now what is happening? When Bob want to send a message to Alice, first he need to know the public key of Alice. Otherwise, Bob want to send a message to Charlie, he need to get the public key. So these green color keys should be kept secret. You should not share with anybody. So each party has 2 keys. So what is the main use of each key is public key, public to anybody. Use an encryption and verify the signature. Okay, that is the point where you need to concentrate here. Just encrypt the messages and verify the signature. So in public key we told that is an encryption process, but in addition to that, this key also play a role in the case of your digital signature. So what the role it is playing here is, it verifies the signature. So now we can able to understand, come out with very important point here is how your public key is working, how your digital certificate is working, right? Digital signature is working. In public key cryptography, public key is used for sending the encrypted message. In the case of your private key, where it is used for decrypting the message. In other word, if you are relating with a digital signature, the public key is used for verifying the signature, private key is used for signing or creating the signature. So now we need to differentiate the role of the key during each and every process. A private key known only to the owner, public key known to anybody. So, used to decrypt the message. Who is it using for decrypting the message? Public key, private key, and signed signatures. So, two role the public key is going to play in the case of your cryptography. So, private key, one thing is it is used for decrypting the message, and another thing is signing the digital signature. So, how these keys are differentiated? Very simple example is explained here. Anyway, we have some of the algorithms in the later chapter where we enable to understand here. The public key is 4, the private key is 1/4, the message is equal to 5. So, it is very simple. Ciphertext C is equal to M into public key, that is 5 into 4 is 20. Decryption is plain text is equal to C into private key, that is 20 into 1/4 is 5. So, now we can able to get back the key, get back the message. So, what is the message? 5. What is a public key? So, what is the idea here is the public key, private key is always inverse of private key is always inverse of public key, and also public key is also inverse of private key. So, it is very, very important. These two are related, but it is very, very difficult to derive. By knowing the public key, it is very, very difficult to derive the private key. This is the success of a cryptographic mechanism. So, internet commerce, suppose Bob want to use a credit card to buy some brownies from Alice over the internet. Alice sent her public key to the. So, now the situation is related with how we are dealing with day to day life. For example, I want to buy some information. First thing, Bob want to use credit card to buy some brownies from over the internet. What Alice is doing is, Alice sent her public to Bob. So, Bob used the key to decrypt his credit card number and send the encrypted number to the Alice. So, now Bob is using the key to encrypt his credit card number and send the encrypted number to the Alice. Alice used her private key to decrypt this message. So, get the Bob's credit card. So, now we can able to understand now Bob want to use a credit card to buy some brownies from Alice. So, Alice cannot send the credit card in a plain, that is a open or unsecured channel. He need to encrypt the credit card. How we can able to encrypt is, I need Bob's public key. So, Alice is sending her public to Bob. So, Bob is not Alice public, okay, send her public to Bob. So, now Bob receives the public key of Alice and he is encrypting the public key, encrypting the credit card number and send the encrypted number to Alice. So, Alice use her private key to decrypt the message and finally they get back the. This is what exactly happening in the case of our internet. So, public key encryption, we use the same text, how it is encrypted. You can able to understand here the two different keys, one is public key, another one is a private key. Their role is also different, one is used for encryption, another is used for decryption. So, as we know very well, where your symmetric key is going to be very faster when compared to your asymmetric key. So, all known public key encryption algorithms are much slower than the fastest secret key algorithm. So, what is the idea here is, in a hybrid system, Alice uses Bob's public key to send his secret message, is called session key. Then Bob and Alice uses the session key to exchange the information. So, now what is happening? The symmetric key problem is overcome by the asymmetric key, asymmetric problem is overcome by the symmetric key. So, what is a new key is introduced by this hybrid encryption system is a session key. So, the session key is going to be used between Alice and Bob. The session key is generated with the help of the public key encryption. So, we have discussed about the modern cryptography system, working principle of symmetric key and asymmetric key, and also we have understood the merits and demerits of both mechanism, and the important thing is the digital signature. So, importance how it is going to be play a role in the case of your internet, that is the name called X.509 certificate in the internet. Thank you.